Let's solve this question here. Reaction time can be crucial in avoiding a car accident. You are driving at 75 kilometers per hour north when you notice a stalled vehicle 48 meters directly ahead of you. You apply the brakes, coming to a stop just in time to avoid a collision. Your brakes provided a constant acceleration of 4.8 meters per second squared south. What was your reaction time? Now, let's look at the picture of the situation first. Your car is the magenta car here. The blue car is the stall car. You are traveling to the north side. Let's say this side is the north side. This way. And the distance between your car and the stall car is 48 meters as given in the question. Now, you notice that there's a stall car in front of you. There will be some time pass while you're trying to react to this. And that's your reaction time. Also, your car will still travel forward in the north direction during your reaction time. So, let's say this is the distance your car traveled during your reaction time. And then, at this point, you reacted to the situation. Then you will apply the brakes, trying to stop the car to avoid the collision. So let's say this is the distance your car traveled after you apply the brakes. Okay, so now, first, we should calculate the distance your car traveled after applying the brakes. So that means after you apply the brakes, how far does your car travel before it comes to a complete stop? Now let's look at what information we have. We know the initial velocity of your car is 75 kilometers per hour north. However, this is not the SI unit. We have to convert this into meters per second. So here, 75 kilometers per hour times, to convert kilometers to meters, we have to multiply by 1000. To convert hours to second, think about how many minutes are there in 1 hour. 60 minutes. How many seconds are there in 1 minute? 60 seconds. So 60 times 60 is 3600. And that will give us approximately equal to 20.83 meters per second. So I will rewrite this. .83 meters per second. Do we know the final velocity of your car? Yes, we do. Because it needs to come to a complete stop to avoid a car accident. So the final velocity of the car is 0 meters per second. What else do we know? We know that here, right, in the question, your brakes provided a constant acceleration of 48 meters per second squared south. So the acceleration is 4.8 meters per second squared south. Okay, now we have to calculate distance, right? Or displacement. Which formula should we use? We should use this one, right? V final square equals to V initial square plus 2A times delta D. Because we know V final, we know V initial, we know A, we can calculate D, delta D. Okay, let's rearrange this equation and isolate delta D. V final square minus V initial square is equal to 2A times delta D. Isolate delta D, we get V final square minus V initial square all over 2A. Now we can put in the information here. Delta D is equal to V final is 0 square, right? V final is 0, so 0 square minus V initial here is 20.83 meters per second, so minus 20.83 square all over 2 times acceleration is 4.8 meters per second square south. Now notice that the acceleration is in the opposite direction of where your car is traveling, and it's going to south. So if this side is north, then this side will be south. So this should be negative 4.8 because it's in the opposite direction. So it's the negative side. Okay, so now delta D is calculated as 45.2 meters. Okay, so that means the distance your car traveled after applying the brakes is 45.2 meters. So this distance here is 45.2 meters. Now, then we can calculate the distance traveled during your reaction time easily. It's the total distance, which is 48 meters, minus the 45.2 meters here, right? The distance your car traveled after applying the brakes is the distance traveled during your reaction time. So let me write this. Distance travel during your reaction time is equal to 48 minus 45.2, which is 2.8 meters. So this distance here is 2.8 meters. So during your reaction time, your car traveled 2.8 meters north. Okay, now, next, we have to calculate your reaction time. So let's see what information we have, okay? Now, we do know that the initial velocity of the car is 20.83 meters per second north. The distance traveled is 2.8 meters. Also to the north side. Now, what's the acceleration of your car while traveling in this distance here? Should be 0, because your car is not accelerating forward. It's actually moving at a constant velocity of 20.83 meters per second. And you have not applied the brakes at this time yet during this distance travel, because this is your reaction time. You're not applying the brakes during your reaction time, right? So you only apply the brakes after you reacted. Then the brakes only applies during this distance travel. So there's no acceleration here in this distance travel during your reaction time. So acceleration here in this case is 0 meters per second squared. Now we have to find the time, which is your reaction time. Which formula should we use? Now we should use this one, right? So delta D is equal to V initial times delta T plus 2A delta T squared, right? We have delta D we have V initial, we have acceleration, then we can calculate delta t. Now, basically, delta t here is the time your car travel here, right? But it's also a reaction time. That's how much time it takes you to react, right? So that your car travel in this distance, this much distance, right? Okay. Here. So let's put in the value here. Delta t is 2.8 meters, right? V initial is 20.83 meters per second times delta t plus 2 times acceleration, which is 0, right? 0 times delta t squared. And we know that this is equal to 0. So 2.8 equals to 20.83 times delta t plus 0. 2.8 equals to 20.83 times delta t. Isolate delta t. That's equal to 2.8 divided by 20.83. Delta t is approximately equal to 0.13 second. So 0.13 second is your reaction time. Okay, but what does that mean? That means in order for you to avoid a car accident, it can only take you 0.13 seconds to react and then apply the brakes to make your car come to a complete stop to avoid a collision. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.